In our last lesson, we looked at different elements on the periodic table, and we learned how to determine the number of protons, electrons, and neutrons in a typical atom of those elements. So for example, let's take this element, which is fluorine, and we learned to take a look at the atomic number, the whole number up there, and say that every atom of fluorine has 9 protons. We also said that it has 9 electrons. And to determine the typical number of neutrons in a fluorine atom, we took the atomic mass, which is about 19, rounded off to the nearest whole number, subtracted the atomic mass, and we said that a typical atom of fluorine has 10 neutrons. And that's true. However, we know that the number of neutrons in an atom is actually negotiable. It can change. And depending upon the variety or the isotope of the element we have, it can be different. So fluorine will always have 9 protons. No matter what you do, fluorine's number of protons can never change. Its number of electrons can never change as long as it's considered an atom. If it does change, it's called something else. We'll learn about that in a later chapter. But the number of neutrons is negotiable. And we know that different isotopes of fluorine can have different numbers of neutrons. And so fluorine could have 11 neutrons, 9 neutrons, maybe 12, something like that. And so this gives us our definition of an isotope. Isotopes are varieties of an element, each of which have different numbers of neutrons. And so we're going to take a look in this lesson today at different isotopes of elements, and we're going to learn the correct way to write the symbols for these isotopes, as well as the correct way to name them. And so let's take a look at this atom right here. We have a picture, and let's just see if we can answer some questions about that atom. So first of all, how many protons? Well, we can just count those up. The protons are in red in the nucleus, and so it looks like we have 5 protons. And of course, this atom is not drawn to scale, of course. How many neutrons? Those are in yellow. Well, we count those up, and I'm counting 6. 1, 2, 3, 4, 5, 6 neutrons. And of course, the number of electrons are in black. Those are buzzing around in the electron cloud. 1, 2, 3, 4, and 5. So I'm counting 5 electrons. So the name for this atom is going to be, well, if we look at the periodic table, 5 protons has to be boron. That's not negotiable. Now, the name of the isotope, we add the protons and the neutrons. So 5 plus 6 is 11. So we're going to call this particular isotope or variety of boron, boron 11. That's how it's going to be called. And so that's the name. Now, I want you to notice the symbol that we write for this. We have the regular symbol for boron, which is a capital B. And then we write that 11 as a superscript right up here. And then the atomic number becomes a subscript. And so there's some names we give these values. The 5 is the atomic number, just like it was earlier. That has never changed. We said the number of protons in boron is never going to change. That's not negotiable. But the number of protons and neutrons together, that could change. That's a value called the mass number. The mass number. Sometimes we give abbreviations to these. Sometimes in chemistry the atomic number is given the designation Z, and the mass number is given the designation A. So you might see that in an abbreviation or in a worksheet somewhere. But the mass number is 11 in this case. Atomic number is 5. Well, let's try a couple other examples. Let's see if we can determine the number of protons, electrons, and neutrons in this atom. Now, if we're going to read that, we read that as calcium-42. Well, the number of protons and electrons will be equal to the atomic number, just like it was in the last example. So that's going to be 20 for each of those. The number of neutrons we have to subtract. So 42 minus 20 will tell us that we're going to have 22 neutrons. And so that's the answer for that particular isotope. Let's try another one. This is an isotope of carbon. This happens to be a radioactive isotope of carbon, as it turns out. How many protons and electrons? Well, the bottom number, the atomic number, Z, always tells us it is 6 for each of those. The neutrons, we have to subtract. 14 minus 6 is equal to 8. So it's 8 neutrons. Let's try another example. Now this time we're given the name of the isotope instead of the symbol for it. So the number of protons and electrons is going to be a little bit harder unless we have the periodic table to look at. So let's look at the periodic table square for neon. And there it is. Can you determine protons and electrons from that? I hope so. It's that number right there. It is 10. Neutrons. How do we determine neutrons? We have to subtract the mass number, 21, minus the atomic number, 10. So that would be 11 neutrons. Let's try another example. This time we have to write the symbol. Something that has 16 protons, 16 electrons, and 20 neutrons. Well, what symbol is that? It might help if we have the periodic table. There's the periodic table square. We see that it is sulfur that has the atomic number 16. So we're going to put an S here. And where does that 16 go? On top or on bottom? It goes on the bottom. And the number that goes on top, the mass number, well, what should that be? It's the sum of the protons and the neutrons. So that would be 16 plus 20. And so that would be 36. And so 36 would go on top. So that's the symbol. If we were going to name this, we would call this sulfur 36. Let's try one more example. We're going to write the symbol again. 38 protons, 38 electrons, 50 neutrons. It might help if we have the periodic table square for the atomic number 38. And there it is, 38. So that would be SR is the symbol. What number goes on the bottom? It would be 38, the atomic number. What number goes on top this time? Well, it should be 88, shouldn't it? Because it's 38 protons plus 50 neutrons. So when you add the protons and neutrons to get the mass number, it's 88. So that's the symbol for this isotope. If we were to write the name for it, it would be strontium 88. So hopefully by this point you can write the symbols, write the names, and interpret the names and symbols for any isotope designation that you might be given in chemistry.